Okay, so question number 11 kind of asks us to do everything in terms of projectile motion, and we'll just kind of go through it one question at a time. The first part is asking for the horizontal and vertical components. So what we know is that this projectile is fired at 10 meters per second, and that's at an angle of 24 degrees. So I have a 24-degree angle here relative to the horizontal. That's just relative to the ground. Now, A and B is asking for the two components of this velocity. So that's the actual velocity. In A, it asks for the horizontal component. So I am going to be finding this component of the velocity. And then in B, it asks for the vertical component. So I'm going to be finding that component of the velocity. We do have this 24-degree angle. So to find the horizontal component, I'm going to use cosine. So the cosine of 24 degrees is equal to my adjacent side, which is my velocity in the x direction, divided by my hypotenuse, which is that 10 meters per second. And then when I go cos of 24 times 10, I should get 9.1 meters per second. To find my y component, well, this will be the sine of 24 degrees, and that's equal to my velocity in the y direction divided by 10 meters per second. And then when I multiply that, I should get that 4.1 meters per second. Then it asks for maximum height. So I guess now to kind of answer the next couple questions, let's split up this question into what we know. So I know in my x direction, my velocity is 9.1 meters per second. I know that should be an m. I know that in my y direction, my initial velocity, I'll say up is positive. So my initial velocity is positive 4.1 meters per second. My acceleration is negative 9.81 meters per second squared. And if it's asking for maximum height, well, I'm trying to find the place where my final velocity then is 0 meters per second. And I want to find the distance to that point. So I do have this equation to solve for that. I have VF squared is equal to VI squared plus 2AD. So VF is 0, so I have negative VI squared equals 2AD, so negative VI squared divided by 2A should give me my maximum height. So VI 4.1, and then that's squared divided by 2 divided by 9.81. And I get 0.86. So I get 0.86, and that's probably okay if I'm using this 4.1 value. If you are using the value here with all those nice decimal places, then you would get 0.84. So our distance is 0.86 meters. Maximum height. The time the projectile is in flight. So we're going to deal with this y direction again. I'm maybe going to erase all this stuff. So now to find the time, we know our VI is plus 4.1 meters per second. When we were talking maximum height, we were talking about this point. So that's kind of the point halfway in between. So if you use that final velocity of 0, you'd have to multiply that by 2 to get the full height. I'm going to use VF is negative 4.1 meters per second. My acceleration is 9.81 meters per second squared. And then I can find out what my time is. So acceleration is VF minus VI over T. So T is VF minus VI over the acceleration. 8.2 divided by 9.81. That's 0.83 seconds. Now the important part for this last question is this time is the same for both dimensions. So if that is 0.83, now this is 0.83 seconds as well. The x direction is uniform motion. So I'm using just this velocity as distance over time, uniform motion formula. Velocity times the distance, time will be my distance. So 9.1 times 0.83 gives me a horizontal distance of 7.6 meters. Let's get to that last question again. We got to take this time. This time is the same for both of those dimensions, and then we can go from there.